So today we're going to be taking a closer look at the intermediate value theorem. This is something that is vital to the construction of calculus. It is not as vital in terms of day-to-day applications. So this is one that we need as the underpinnings and the sort of part of the engine under the hood to explain why some of the results in calculus work, but it's typically not the end result. So what the intermediate value theorem says is that if you have a function that is continuous on some closed interval from a to b, so the domain includes the closed interval from a to b, then there is at least one point in between where, let's say that f of a is less than f of b. It could easily be the other way around, but we figure out what the value at one endpoint is, what the value at the other endpoint is, and for any given value in between there's going to be a point c, where c is in the interval ab, where that's true. Now the mathematical formalism is a little bit convoluted, but here's what it boils down to. You've got a box. On one end of the box, your function has this value. The other end of the box, your function has that value. Now the intermediate value theorem says that if you pick any y value in between, as long as your function is continuous, then there's going to be at least one point in between where the function has that value. It might hit it exactly once. It might hit it more than once, but there's going to be at least one point where it hits. So really all they're saying is that if it's continuous, you have to cross that line in between. So there's an invisible line at the value that you're looking for, and there's going to be at least one point on that line that intersects with the curve. This is it. So as I said, it's pretty fundamental to the underpinnings of calculus. But in terms of the day-to-day stuff, it's really quite intuitive. You just have to make sure your function is continuous. Because if your function is not continuous, if it goes here and then jumps up there, that's fine. It's not continuous. It does not have that intermediate value. It doesn't apply. There's also nothing saying that your function has to stay in this box. It could come down and above and below and above. So these are not necessarily the maximum and minimum of your function within that range, but it must take on every point within that range, or every value. It doesn't have to take on values outside that range. You can look at values here and you can look at values here. You can't guarantee it. So as long as the function is continuous, and f of a and f of b have different values, you can prove there's at least one point in between that takes on any value in between the function at those endpoints. That is the core of the intermediate value theorem.